Happy Sunday, everybody. Welcome to another episode of our Sci-Fi Sunday. Today we're focusing more on the sci, less on the fi. We are joined by the lovely Kirsten Banks.
I like this.
As many of
I
you
like this.
probably remember her.
Yeah.
And the lovely Steve McRae,
See, I do that too.
of course. Of course. Um, Many of you probably remember Kirsten from the flat Earth discussion with Debbie Duran. How could you forget that? She is actually, I guess, crazy enough to agree to come back on for more. So we thank her for taking the time out of her schedule, especially from down under. So, Kirsten, welcome back.
Thanks for having me again. Honestly, the first time I was hooked. I can't stop. I have to keep coming back.
And we thank you for coming back after the newfound fame that you have.
Yes.
Gracing us again with your presence.
Yeah.
We're kind of humbled. Yes. You want to tell people about that experience real quick? Because I think that's funny.
Please.
So a couple of days ago, I was doing my normal day/night job at Sydney Observatory, and I was standing at the desk, and someone walks in and is like, "Hey, you're the girl from the space talk about the flat Earth debate." I'm like, yes, I am.
You're the one that talked to that crazy chick for 2 hours, so you're more crazy than she is. That's what they told me.
The person who comes to me is
That's
like, how do you have that much patience? I'm like, look, I'm just a secular saint, as some people say.
The biggest question I got was,
I was
how much
getting ready to
alcohol
say,
were you
most
drinking?
people in the chat were calling you a saint.
Yeah.
Saint Kirsten.
Yeah, they're like, how much has she
so-
had to drink? That's what the biggest question was.
Had to be a lot.
It was all water.
Yeah. Yeah, well, vodka.
H2.
Yeah, this is water too.
So
I call it vodka. But.
Before we get into tonight's talk, let me just go over a couple of things before we begin. Don't forget that this Wednesday we have a huge discussion with Aaron Ra and Jeranism, two YouTube giants, are finally going to come together to discuss proof for the shape of the Earth. And if you stick around with us until the end of this broadcast tonight, we will actually be teasing a little bit of that discussion. We've put together kind of a trailer between the two so that you can kind of get a feel for what's going to be happening. So stick with us till the end, and we'll preview that. Also, coming up in about 2 weeks, we have... Pardon me?
I said real quick, spoiler alert. It's round if you don't want to have to watch it. Just,
Well,
I know I hate to throw out spoilers, but it's round.
And then coming up in about 2 weeks now, we have Matt Dillahunty and Inspiring Philosophy. That's going to be a discussion on if religion is a positive influence in society today. So two really big discussions getting ready to come your way. And so I hope everybody's ready. I hope we're ready. I wonder sometimes, but I think we are. I think we're good. Steve, anything you'd like to add?
No, I just want to start talking about gravity because I'm still wondering if it exists or not. I'm confused on all this.
Well, let's hop right into it. Let's hop right into it then. So I figured tonight we would focus on in the science realm things that we actually do know and things that are kind of we're trying to learn more about. And to me, I think the most interesting aspect of life is what's up there and what's beyond. It's hard to wrap your mind around sometimes the universe and its kind of infiniteness. So I think the two things that we know exist but we can't actually show for it are gravity and dark matter. So I figure we'll start at those two places and then just kind of see where we go. If you guys have any questions, please feel free to ask them in the live chat or tweet us at Nonsex Show. That's NONSEQ Show. And towards the end, we'll make sure to ask your questions. And it doesn't have to be on gravity and dark matter. It could be on anything in the cosmos. So rack your brains and ask us, and we'll make sure that we get those answers. So, Kirsten, I guess go ahead and kind of give us a general overview of, let's start with gravity. What is it, and why can't we show what it is?
Well, it depends on how you want to approach this question. if you want to talk about it as an interaction between two bodies of mass, then all you really have to do is draw a mass diagram. So anything that has mass in the universe has some sort of gravity to it. They have some sort of gravitational field. So myself, the Earth, you two, everyone watching this, you all have gravity because you have mass. And you are currently interacting with the Earth. Is that going to make sense?
So far.
So far?
I think I got it. Yep, I think I got it. We're right there with you.
Yep, cool. Just imagine because I love my pens, we're going to go with the pen example again from last time. So this pen has mass, so it has gravity. So imagine we have the Earth here. There's an arrow pointing this way and an arrow pointing this way from the Earth because they are attracting to each other. So essentially, what's really mind-blowing to me is that when I drop this pen, the Earth is actually also attracted to the pen.
You've just lost every flat Earth in the live chat right now. They're lost. You got to break it down easier for them.
Fair point.
So basically, the pen is exerting a force in the Earth, and the Earth is exerting a force in the pen, and so with the pen's falling, the Earth is actually moving up as well, but a much smaller amount.
Exactly. Yes. So it's a great question of if everyone on the Earth picked up a big rock and threw it in the same direction, could we slow down the Earth's rotation? What do you guys think about that?
No.
No?
Well, the Earth would have an opposite reaction.
I don't think we could.
Like you'd be on a skateboard and you throw something.
Could we?
The impulse, yeah.
Exactly. So equal and opposite forces, just one of Newton's laws. Anything
what did Newton know, man? He was proved wrong by Einstein, from what I understand.
Was he?
Well, according to flat earthers, they tell me this. I'll play the part of the flat earther because that's what they tell me. They're like, Newton
Steve's
was wrong.
playing devil's advocate.
Yeah.
Steve's playing devil's advocate. Too.
We're going to make this difficult for her. We made it easy for her last time. She only had Debbie. She got me now. Yeah.
Oh, no.
Yeah.
So, I mean, but
what makes different, like, the gravity, on Earth, what makes gravity on other places like the moon and Mars? Why do they have a variance in gravity? Why is it not all the same across the board?
So in this case, it's how much mass there is. So the moon is, we'll go with lighter, not that it's necessarily a weight sort of thing, but the moon has less mass than the Earth does, and so its gravity is less than the Earth's. Same with Mars. Mars is smaller, Mars has less mass, and so there's less gravity. There's a smaller force between yourself and the moon or Mars or the Earth, depending on the mass ratio.
Got it.
So the force
is
directly
why can't we...
to that, right?
Yeah. So the force is, you've got the two masses on top of the equation, and then you got the gravitational constant and stuff down there and other things.
No, the gravitational constant.
But it's directly related to mass between
G's on top. GM1, M2.
Yeah.
Okay.
Yeah, it's somewhere in there.
We know G's on top. Boy, that sounds strange.
This is what we need formula sheets for.
Yeah. G likes to be on bottom, but G's on top.
So why can't we... I know that gravity is a theory, correct? So many people, especially flat earthers, they're going to come at this like it's not a fact. It's just something that's hypothesized. Why can't it be something that we can actually prove, without a doubt? Or can we?
Well, there is very strong evidence for gravity. Like, we can measure it. We can, the measurements match the theory. And so people like that, I'm not sure how they can refute it. Like, from my knowledge, there doesn't seem to be much counter evidence to gravity, which is the really silly thing, I think. Because there is lots of evidence. Sorry?
I think the biggest argument was things. What was it that Debbie said? Things fall, or that. What was that quote that she used? It was. It was brilliant. You drop.
They drop because of reasons.
Yeah.
Something like that. Something like
Well, I mean,
that.
they'll pull out this whole buoyancy and density thing, but they don't seem to realize that buoyancy and density require gravity, so I don't know how it really helps them.
It's literally the equation. Oh.
So what would happen if say something like Jupiter, if it were closer to Earth, what kind of effect would that have on, because of its gravity and because it's such a large body planet, what kind of effect would that have, or would it have an effect on Earth anyway?
It most certainly would have an effect on it, because if it's closer, like the relationship between two bodies of mass really require the mass itself, but also the distance between the two. It's a 1 on r squared, 1 on distance squared relationship, so inverse squared thing. So if it's closer, when we're orbiting around the sun, if we get closer to Jupiter at some point, let's say around here, it will affect our orbit in a way that it will actually, depending on how close it is, ever so slightly, it will alter the orbit.
So there's an interesting, I think, well, right now it's a theory, and we spoke about this last time, I believe. Actually, I think when we were watching the Mike Hughes Rocket Man and the cowboy riding a pizza. I think we touched
that was
on
the geek room.
Yeah, it was. It was. But we touched on the fact that they're speculating that there is another planet that has an elongated
orbit.
Yeah. I'm missing the simplest of words.
Highly eccentric orbit. From a planet somewhere in the Kuiper Belt.
Yeah.
Or cloud.
Now that would happen. That would be due to gravity, correct? Due to the fact that it's not able to escape the sun's gravity, and that's something that it would keep it in that kind of orbit.
Yeah, exactly.
So what's your thoughts on that? Do you think that that's plausible? Do you think that there is another planet out there?
It's definitely plausible. Like, let's go back a couple of years when we discovered Neptune. Neptune wasn't discovered by actually seeing it to start off with. Neptune was first mathematically theorized to be there based on predictions and observations of other objects around where Neptune is. So we didn't actually find Neptune, so to say, when we discovered it. We mathematically showed that it could or should be there. So I think that this could be very well the same thing for hidden planet Nibiru.
Well, I wouldn't be Nibiru. I mean, I think there's a real planet out there. I don't think it's Nibiru, but I mean, there's obviously I don't believe Nibiru, but I mean, there are other planets I'm sure that are out there. But yeah, it doesn't come into our orbit. It doesn't do a Velikovsky thing where you have planets going out like billiard balls, and However, what would happen if we had a rogue neutron star decide to come pay us a visit?
Oh, no, thank you.
It would be bad.
I'm just gonna.
It would demonstrate to flat earthers that gravity is a real thing.
Oh yeah.
Because we'd be dead and it wouldn't matter anyways.
That's true, but I wouldn't be for a neutron star coming our way. That would not be fun.
Oh, I think it'd look awesome though. I mean, you'd be dead pretty quick, but it would still be awesome.
Well, yeah, you could actually measure. Well, probably I don't know. You might be able to measure the actual degeneracy, but you could actually see it close up. That would be pretty cool.
You might have to explain what neutron degeneracy is.
That's a good point.
Yeah. I mean, you're throwing out these terms, and I could probably tell you they're probably not sure what neutron degeneracy.
I was getting ready to ask. I was getting ready to ask.
It's just
it doesn't mean they're degenerates like the neutron stars are degenerate.
Yeah. So essentially, with a neutron star, these are really, really, really dense stars. Like a teaspoon of a neutron star would weigh the same as Mount Everest. A teaspoon.
What?
So, yeah, right? It's so cool.
It's so dense that if you dropped like a golf ball size of it, it would actually literally fall through the earth.
Yep. It's insane. But anyway, so because it's so dense, the gravity is so huge, so there's a lot of mass in there. The only way for it to not fall into itself and implode is because of this quantum mechanical feature called neutron degeneracy. So because neutrons are, what are the particle names? I'm forgetting them. Essentially, if people know about the Pauli exclusion principle, essentially these particles can only be on certain energy levels, and only one particle can contain one energy level. So let's say this is an energy level, only one particle could be here. Another energy level, only one particle can be here. Two particles cannot be in the same energy level. Okay, so based on
two spins of the same energy level cannot be in the same quantum mechanical orbit.
Yeah, exactly. So once essentially these particles want to be on their lowest energy level, because that's the easiest place for it to be. So they will fill up all of the lower energy levels and then keep filling up all the higher and higher energy levels. And because there's only so many energy levels that are there, you have this extra degeneracy pressure that pushes outwards and holds the actual star up.
But that's what you described is electron degenerative pressure.
Yeah, and neutron.
Well, yeah, but actually, correct me if I'm wrong, but the reason you have neutron degenerative pressure is because at a certain point, the orbitals collapse and the protons absorb those electrons and then turn into neutrons. What you have left is basically one giant neutron, speaking quantum mechanically. So, because all the nucleons are there are now neutrons, and that's held up by neutron degenerative pressure because you cannot collapse it any further. And then if it actually gets more massive, which is, and within the Schwarzschild radius, then it becomes a black hole.
Yeah.
Right, Kyle?
Physics.
Kyle just has. I've never seen Kyle look like that before. Dude, he just had this blank look. I love that.
I will never in my life deny that anything to do with math is not going to be my strong suit whatsoever. But I will happily look like I'm following along and smile and nod my head until it's my turn to ask a really simple question that has nothing to do with quantum physics or anything like that.
Is that the best way? Yes.
Which is what, like right now. So if taking the whole concept of mass and gravity, gravity being that things with mass are being, kind of pulled towards each other. Is there an end game in terms of the universe where we're all being like pulled together to, a certain point, or how is that going to work? Basically, Kirsten, look in your crystal ball and tell me how the universe is going to end. Are we being pulled towards somebody else's mass or what?
Okay, so in the short term, as in a few billion years from now, our galaxy will collide with another galaxy, Andromeda, our nearest neighbor. So we have that interaction there. On the whole big scale and longer scale of the universe, there are three ways the universe could end up. One is the Big Crunch, which I love it because it's a great name. The Big Crunch, where we've had our Big Bang explosion, we're going out, we reach a point where we kind of like stop and then come back in again and then collapse back down to a big crunch. That's one option. Second option is
Clever name.
kind of like, second option is kind of like, I think it's the Big Freeze, where we have our Big Bang explosion and we kind of slow down, but we just keep going and just cool down so much that the entire universe freezes over. That sounds fun.
Those sound fantastic.
Right?
Yeah. The heat death. Is that?
That would be called heat death.
That's right. Yeah. That's the heat death one. Also exciting. The Big Freeze then is the one that just continues to expand and just keeps expanding out. So those are the three options we have. I think at the moment we're going for a heat death.
Ever heard of the Big Rip?
Oh, the Big Rip. I don't know. I've heard of it, but I can't remember exactly the details about it.
It's strange. It's too weird to even go into. I know very little about it. It's just something about like space-time literally rips, and I don't know what that would mean. So, but yeah, that's called the Big Rip.
I don't like any of these options.
They're not good endings, are they?
Where we. So I hear that from what I do follow, and
That's
I'm
okay.
obsessed
It's
with
like
like
billions
space.
upon billions of years away.
So wait a minute.
But
Wait one second.
we're expanding at a rapid rate though from the Big Bang, correct? Like, I believe that they thought we were at a kind of a steady pace, but when they ran the numbers and actually saw that we're expanding at a quicker rate than previously thought. So it looks like the big freeze would be the most reasonable way that it would end, right?
Possibly.
We all die in the end. Does it matter?
I mean,
no one gets out alive.
In 5 billion years, the sun will be dead anyway, so
yeah. So basically,
what will happen to us when we collide with Andromeda? Is that something that is survivable, or will that just like redo the whole thing?
Well, that won't kill us because before then the sun will have expanded and the Earth will just be a molten ball of lava.
Fantastic.
Again, nobody gets out alive.
Nice.
Yep.
So there's another option, I guess, that could ultimately destroy us, and this happens to be something that you said earlier that you wrote a paper on. Are we in danger of black holes or dark matter, and what exactly are those?
Black holes and dark matter. Ooh, we're getting into the hard stuff now. So dark matter, we'll start with that because it's a bit of a weird and wonderful thing. And I hope I remember most of the stuff I wrote in my essay from 3 years ago. So forgive me if I don't, but we'll see how we go. So dark matter, it's kind of like this weird and wonderful thing that should be there, but we can't see it because it doesn't interact with light, like any form of light, like X-rays, gamma rays, visible light that we can see, and all the other ones as well. So, but we can kind of see how it should be there based on, remember going back to Neptune and Planet X, how we mathematically see that this stuff should be there, a planet should be there. Same thing with dark matter. We look at a galaxy and how it's moving, and we see that there should be some other stuff based on our gravity model. There should be some other stuff out there that's causing these interactions to happen. But because we can't see it, it's matter that's dark.
But the flat earther will say, well, we can't see it, therefore it doesn't exist.
Yep.
She's like, oh, God, math flat earthers.
Hey, Tom. That reminds me, somebody gave us the suggestion, which I think is genius, that we need to start selling oven mitts with non sequitur on them for all the many times that the audience face palms while watching our show.
It's face protection.
I like it.
So what exactly are they, Kirsten? Like how what makes us think that this even exists? What is it doing out there in space?
Okay. I want you to imagine a galaxy, like a nice little spiral, or little spiral galaxy. So you have this big spiral structure and you have a halo in the middle, kind of like a pancake sort of thing. I like how you're imagining this, Steve. It's great.
I'm working, doing the visual. This is my sign language for the people. Go ahead. I'm visualizing.
Yep.
Okay.
Yep. So you got this big spiral structure, kind of like a flower, if you like. And we'd have a look at what the stars are doing and how they're moving in a radial direction. So not in a radial direction, like in a radial relationship. So stars in the middle will be moving at a certain speed. Stars further out should be moving slower. But the further out you go, these stars are actually moving a lot faster than they should be. So we believe that there should be something else out there, some other matter that's driving this force and making these stars move faster than they should be. So that's kind of the basis of dark matter.
Yeah, okay.
Interesting. Now, is that different from a black hole?
Yes.
Different from a black hole? Well, that depends on what black hole you want to talk about too, actually. But a black hole is a point in space that has such a such a high gravitational field that not even light, a massless particle, can escape.
Interesting. Okay, what happens when something comes in contact with a black hole?
Well, let's say, for example, we go into a black hole. And I love this explanation because it's so much fun. It's kind of existential crisis inducing, so bear with me. But if we were to go to a black hole...
Yeah, they didn't tell me philosophy was going to be involved here.
I don't think so.
Existential's philosophy.
It's just...
That's what philosophy does. Never mind.
Okay, so let's say we're going to a black hole, and we go in feet first. So as we're going in feet first, our feet are getting, because of the relationship of gravity between you and the black hole, the gravity on your feet will be a lot stronger than the gravity on your head. So that means you will get what's called spaghettified. You get strung out like a
nobody gets out alive.
No way.
Yep.
Now there is a way around that.
That's
though.
crazy.
There is a way around that. If you have a super massive black hole, the gravitational gradient will not be that great, and you can actually survive falling into the event horizon without being spaghettified. But but the problem is with that, you still don't get out alive. You just prolonged your agony for about half a second or so. But yeah, you can actually fall into certain types of black hole on the event horizon and not even notice. But after that point, you're pretty well screwed.
Yeah.
How do they know that though?
Math.
No.
That thing that flat earthers say is all like mumbo jumbo, scribble scrabble.
I mean,
could there be any truth?
It does look like that.
Could there be truth to math?
Could there be any truth to the fact that a black hole will take you to another parallel universe?
Well, there are theories that a black hole could take you through to a white hole, which will be not only a different point in space, but a different point in space and time. So I guess that would be a parallel universe in a way. But
again, you don't get out alive. The problem is you wouldn't survive it.
Yeah.
So it was one of those things. Yeah, but even if it was true, so what? You'd be dead. Does it do you any good? We're really into an existential thing where we're all going to die. No matter what she says, someone dies. This is getting depressing.
Yeah, all the outcomes are really bad for all of us.
Every one of them has bad outcomes.
You wonder how I stay so positive and happy these days. I'm just like, it's all relative.
The universe is not a place conducive to our existence. It really isn't. Most of the universe is completely inhospitable to us.
This is true.
But I think with the discovery of all these, I think with the discovery of all these exoplanets, this is an interesting question or an interesting way to go. There are literally, I think, billions of exoplanets, right? What are the chances that other planets like Earth exist in a habitable zone around their star?
Well, there are a lot of planets that exist in the habitable, the place where you can live, in that zone around stars, like the heaps that they've discovered so far. And also, let's do just a bit of numbers here. It's going to get fun, by the way. Let's do the numbers. It'll be great. So,
I'm just kidding.
All right, all our viewers just left. You start talking about math, they're gone.
It's fine. It's just smile and nod. It's all good. Okay, so let's say our galaxy is a pretty average-sized galaxy. Well, technically kind of small, but let's say it's average-sized galaxy. It has a few 100 billion stars in it. Okay, there are believed to be up to about 10 trillion galaxies in the entire universe. So if anyone can do the math for me, 10 trillion times 100 billion.
Yeah,
that's quite a few stars.
Shit ton in America. That's the name for it. Metric shit ton.
Wait, but I didn't think you knew metrics in America.
Yeah, well, that's what we call it, a metric shit ton. We don't know really what that means. Some of us did learn.
She come firing
anyway.
Just because things like feet and inches confuse you down there, we understand.
Fair point. I do enjoy the tit tap. Anyway, so we've got a metric shit ton of stars. It's believed that there are, for every 10 stars in the universe, there is one planet on average. That is still a lot of planets. Surely there must be at least one other planet like Earth.
Yeah, TRAPPIST-1, I think.
And what would the chances be that?
Uh-oh. Kyle, you keep losing.
What would the chances be that that planet harbors life like ours? You think? I know that's a hard question to answer, but you personally, do you feel that We are alone or we are not.
Either way, it's a terrifying answer, I have to say. Either
True.
we are alone or we're not alone, and both are terrifying. But honestly, surely there must be some sort of other life out there. And like when I say life, I don't mean like an identical Kirsten in another identical Earth billions of light years away. I mean like microbial life, like little tiny things, microbes and stuff.
Yeah.
But why not intelligent life? I mean, we can't.
They think
We are the only species that we know of that can actually interpret the universe. That's a scary thought. We are the only ones that can actually understand the universe. So why is that the case? I mean, could there not be other sentient beings on other planets that also have that ability?
Potentially. I mean, I honestly don't know, but it's a fun thought to exercise.
And once they find out we're here, they're going to be using us for food.
Maybe.
Yeah, that's a scary thought. Nobody gets
Oh,
out alive.
how you
Nobody
know
gets out
they're
alive.
not already, Steve.
Yeah.
Steve, we've talked to several people over the past Sci-Fi Sundays that would say different. That we actually have been.
Yeah. See, I think this planet's on quarantine if they
visited.
exist. There's like a no-fly zone for UFOs and says stay away from this solar system.
If I was an intelligent species from another planet and flew by Earth and beamed down and saw that you know we were obsessed with things like the Kardashians and other shit like that, I would be right back up in my spaceship and getting the fuck out of here as quick as possible. You know, there's no intelligent life anywhere on Earth.
Does anybody remember How to Serve Man? It's a cookbook. Twilight Zone. People are talking about a live chat. There was a Twilight Zone episode a long time ago called How to Serve Man. I think was the title, and basically it ended up being a cookbook. Spoiler alert: the aliens were like taking people to their home planet, and ended up eating them.
Fantastic. I have a couple people alive that I would recommend for that. I think.
Yeah, nobody gets out alive. What's that?
So.
Did he?
Are we good?
You freeze?
Real good?
I don't think so.
Yeah,
I think we're all still here.
Yeah, we're still alive. We're not eating yet.
Yep.
So, Kirsten,
I didn't fall off the.
Let's say safety check. Did your harness not fail? I mean, spontaneous failure of your harness is a very, dangerous thing in Australia. Spontaneous.
I think it's a real risk.
You are upside down. You are upside down.
Yeah. I could flip her image to make it, actually the way it actually is.
That would actually be funny, but let's not do that. Let's talk about you a little bit personally and why you got involved with what you did in the first place. I think you kind of have an interesting with the Aboriginal aspect of it. Tell us a little bit about that, and then that cool story about the emu.
Yeah. Okay. Well, where do I start? We'll just start from the beginning.
At the beginning.
Ever since a young girl, from like primary school, I've always loved the sky. But in primary school, I wanted to be a meteorologist and study the weather. So I love storms and everything. Plus, like when you're in kindy and you're going around the room saying what you want to be, most girls would say, I want to be a ballerina or a vet. And some boys would say, I want to be a fireman or an astronaut. And then it comes around to me, itty bitty little Kirsten, and comes out and says, I want to be a meteorologist. Even my teacher didn't know what that meant. So I felt pretty good as a little kid. biggest 5-year-old who knows like the biggest word ever. So in primary school, I loved storms. I would watch like storm chasers on TV and everything. It was really fun. But then in high school, I went to the IMAX theatre in Darling Harbour in Sydney. Like these had this massive, massive screen. We watched the Hubble documentary. And when I was watching all of these awesome photos pop up on the screen, I was like, I want to do that. That's what I need to do. So I started studying physics in my higher education, and I just started to really get involved in astronomy. But with the Aboriginal astronomy part, I always knew that I was Indigenous, but I didn't know exactly where I came from. So in my first year of university, I got a job at Sydney Observatory, still work there now. It's great. I was walking past an Indigenous map of Australia, which is has lots of colours on it representing over 250 different groups. And I looked at it and I thought, where do I actually come from? You get to that point in life where you have that philosophical questions like, who am I? I had that point 3 years ago. And I went home and did some research, and I found out that I come from a country called Wiradjuri, which is now known as Central New South Wales. And my family, my mob, comes from Condobolin, or as we call it, Condo. And after learning about that, I just went off and got hooked into learning more about this Aboriginal astronomy and how their star stories are not just stories. Within them, you have thinly veiled astronomical concepts in those stories, and it's amazing to find them and extract them out there and just to see how much they actually knew from over 65,000 years ago. It's just amazing. And for example, the emu in the sky, in my country we call that Gugurman, and depending on its position in the sky, it indicates when the right time is to go looking for emu eggs. And that has worked for over 65,000 years.
That is crazy.
It's so cool. I'm in love with it so much.
What for people who may be wondering, kind of tell us what it means to be Aboriginal in Australia. Can you kind of go into that and the history a little bit about that for people over here who may not be familiar with that kind of Australian history?
Okay, so essentially, I'll try and do it in a bit of a basic term and not get too into it. So essentially, to be Aboriginal or an Indigenous Australian, before English settlement in 1788, the Australian continent and its islands and the Torres Strait were inhabited by these Indigenous Australians, or the Aboriginal people. And they've been using the land and using the sky for tens of thousands of years, although who knows, it could get to hundreds of thousands soon when we do more research. And it's descendants of those people who are Indigenous. So if you technically want to, a lot of people ask me, oh, how Indigenous are you? And that's honestly a bit of a sensitive question because you either identify or you don't. It's not this sort of fractional sort of thing. But for those who do want to know, my great-great-grandmother and grandfather were full-blood Aboriginals. So that would technically make me a 16th, but I identify, I do the research, I immerse myself into the culture, so I say that I am Indigenous with that background as well from my blood. So that's essentially what it is, because in the history there was the stolen generation, which essentially if I were born 60 years earlier, because I'm a mix of Indigenous and non-Indigenous blood, I would have been taken away from my family, which is an awful, awful situation. But that was part of the history and that did happen. So, yeah. It's
really? I didn't even.
Yeah. Yeah, it's a long history and there's a lot in it.
That I didn't know that aspect either. I mean, I knew a little bit about the kind of Aboriginal culture, but not that they would get taken away. That's depressing.
Yeah, but thankfully we learn from our history and it's getting better. And what I really want to do in my life is I want to be an advocate for Indigenous knowledge and to get that sort of appreciation that, well, everyone deserves some sort of appreciation and respect. And so I want to work for the Indigenous people of Australia to get that appreciation and respect, that mutual appreciation and respect from other people.
So what's your favorite aspect about what you do in especially at the observatory? What's your favorite, I guess, part of space that you like learning about or showing off to other people?
Oh, that's a good question. There's so much. I would say that my favorite part about my job and everything that I do in life is inspiring people and exciting people about space. Because usually when I start a tour, I am the weird one in the room because I'm the one that's really excited, super hyped up about space, and everyone's like, okay, cool, chill. But then once they get on board and once they get excited and like reach my level of excitement about space, then it's just so much better. I love doing that, just getting people excited about the space and the cosmos.
You have a show coming out shortly, correct? Where you're actually going to be a sort of a celebrity here. Tell us a little bit about that.
Yes, a few weeks ago, I was approached by a French filming company, and they're making this kind of documentary, but it's set like a movie in a way, called Cosmic Flows. That's all the Indigenous astronomical knowledge of many Indigenous people. So there's the Aboriginal people, there's Polynesian, there's people from France, from America as well, and Hawaii too. And I will be part of the Aboriginal segment of that. So that will be coming out in August. It should be coming out in August in America and Canada and Germany and Japan and France. So I will be actually on your TV screen soon.
That's exciting. We have like a don't forget us little people when you make it big now. When you're like Brian Cox and Neil deGrasse Tyson.
Of course. I would never forget you guys.
Real quick, I have a something that I learned probably a couple weeks ago. I was watching a documentary on Galileo, and when they first discovered Saturn, it was really interesting how the way that the rings looked in the telescopes that they had at that particular time. They couldn't tell if it was a planet with rings or if it were two kind of fused planets that they couldn't really explain. But when Galileo relayed his findings to the Vatican Church, there was a Vatican official that declared what he thought was accounted for the rings of Saturn, or what we know now as the rings of Saturn. Does anyone know what he said that those rings were? It's just a little bit of trivia here. Any guesses, Steve?
What was that? I'm sorry, I was taking care of something important. What? Repeat the question for the audience. I know what you mean by that, but can you explain to the audience what you mean by that?
Yeah. Sure.
I do the Hovind thing.
Before they knew that the rings of Saturn were actually rings, Galileo had taken his findings to the church. The Vatican official had declared what he thought the rings of Saturn actually were. And this was before they knew they were actually rings of particles and stuff. What did he say that the rings were actually
I don't even
back
remember.
then? Kirsten?
I'm not sure. This is the first I've heard of this. So it sounds really interesting, actually.
Well, the answer is just it'll blow your mind. But he actually declared that the rings of Saturn were the circumcised foreskin of Jesus that had ascended prior to Jesus's
sure, why not? Let's go with that.
Spirit into the heavens. That's true.
No, you know what? Not even the greatest thing I've ever heard. You know.
So there you go, Kirsten. I was able to teach you something about the rings of Saturn being Christ's circumcised foreskin. Well, that is a true story.
Like I said, not even the strangest thing that I've ever heard. Does that tell you?
Yeah. That does say a
so
lot.
Far,
wow.
So, Steve, are there any questions from the masses so far?
Well, they like to know a bit more about primordial black holes. It seems like. You know anything about primordial black holes?
I don't know a lot, but I know one of my colleagues did her PhD on primordial black holes. So
I don't know what they're asking about it. I mean, are they asking if they think that primordial black holes are still around, or can we, a better question, can we reproduce primordial black holes? Well, they wouldn't be primordial, obviously, but can we produce similar ones to primordial black holes?
I don't know. Maybe. That's not really my probs. Hey.
I mean, I don't see why not. I mean, I guess I don't think CERN's going to do it, obviously, but they're not the energy levels. But when we reach enough energy levels to produce black holes, there'd be micro black holes, which would be similar to the primordial ones. But
yeah,
I would think that primordial ones would all be vaporized by now.
Probably.
Yeah.
I mean, that would make sense. I mean, the universe is pretty old.
Well, it depends on if you're Kent Hovind or not.
6,000 years old, to be correct, right?
6,000, man.
Yes.
What do you make of the theory of transpermia, where life actually originated on another planet, and then a piece of that somehow landed on Earth, and that's where the ingredients for life came from?
Oh, actually, I heard about something similar to this the other day. One of my colleagues at the observatory was telling me about this lady who came on his tour, and he was showing the group Sirius, the brightest star in the night sky, and she comes up to him and she's like, "Oh, can you show me Sirius B, which is the white dwarf in that?" So Sirius is a 2-star system. So you have Sirius A, the bright star that we can see it in the evening, and Sirius B, which is a little white dwarf that's orbiting with Sirius A. And so she asked to see Sirius B, which you can't see through our telescopes. In fact, to actually see it, astronomers had to black out the light from Sirius A just to see a little tiny speck next to it, which was Sirius B. But she asked to see Sirius B because she believes that she comes from Sirius B, a planet that was around Sirius B, that her people came to the Earth.
Yeah, there was actually a tribe.
Wow.
There's a tribe. I think it's called the Dogma tribe? That actually, the narrative was that they knew about Sirius B before we even discovered Sirius B. But if we actually look into the story behind it, it's been completely kind of rewritten post hoc. But yeah, there was supposedly this tribe, and I believe there was a Dogma tribe in Africa that had been known about this Sirius B long before we discovered it. But when you actually look more into it, it wasn't really the case. So. The Dogon tribe. Thank you, Reese.
That's a good.
Dogma?
That's an interesting
Dogon tribe.
That's an interesting topic, though. And Kirsten, I know this probably isn't your forte, but I just want to put it out there anyway. How do you think civilizations like the Mayans and Sumerians and those types knew about the planets in our solar system without actually being able to see them? Because there's evidence that they knew that there were 8 planets in the solar system, but there's no way they could have seen them back then. How in the world would they account for that? Any thoughts?
What do you mean that they didn't see them in a way? Like that they weren't there, or they just...
back then in the BC area and era and earlier, there was no way to see planets like Neptune and Uranus from a naked eye. They didn't have the advent of telescopes back then. So how in the world could they account for these planets being up there without being able to actually see them?
I see what you mean now.
Who knew the planets were up there before we saw them?
The Mayans and the Sumerians.
I'm not aware of that.
Yeah, well, I know that
the Sumerians.
Like back then, you could see Mercury, Venus, Mars, Saturn, Jupiter, and Uranus is technically, the brightness of Uranus is actually just within the limits of the human eye.
Perfect conditions, perfect eyesight is like magnitude probably 6 or 7. I don't know.
Yeah.
So yeah.
Yeah. So, but
the Sumerians actually
they wouldn't have known that.
Yeah,
but they have several tablets where what they did was they counted the sun and the moon as planets as well, but they have 11 planets in their tablets where they actually drew out the orbits, and they got the orbits correct too, but they didn't know that the moon was a not counted as a planet, obviously, in the sun, but they had 11 planets. You take those two out, and then you get the exact number that we have in the solar system. So how they could have known that it just blows my mind.
Yeah.
I think there's more to that story than that. That sounds like a Zachariah Stitchin thing to me.
What?
That sounds like a Zachariah Stitchin thing to me.
The tablets and stuff like that you can pull up anytime and look. I mean, they're there for your sight to see. I mean, they have 11 planets counted, and the actual orbit is exactly how it is today.
Oh,
they
wow.
just counted the moon and the sun as that. It's really interesting.
I don't think Sumerians knew about those planets. Yeah, we'll have to look into that.
Well,
I say it's aliens. It had to be aliens.
How would you explain that?
Because I don't. Well, the explanation would be they didn't.
But how would you explain? How would you explain them getting it dead on though?
I don't think that they did. I first have to determine that they did first. I mean, that sounds like something out of that sounds like something out of In Search of Ancient Astronauts or Chariots of the Gods, or what Zachariah Stitchin used to write about Sumerian mythos. But he didn't even know how to speak Sumerian. He kind of just made it up as he went along, and then years later,
Zachariah believed that there was a Nibiru, though. This doesn't account for that. It doesn't take into account any of the conspiracy aspects of it. It's solely based on.
He did believe in the race of aliens, though, the Anunnaki, which was the aliens that there was from whatever planet they were. Anybody know what planet they were from? Yeah, well, somebody said, when in doubt, it's aliens. That's a good point. When in doubt, it's aliens. So is it like an alien of the gaps theory? Like out of the gaps, alien of the gaps.
This doesn't take into account any of the conspiracy aspects of it. This is solely it's a physical evidence thing, because on the engravings of tablets and their temples that they had, it's got 11 planets. So I mean, either they are really good guessers or they knew something we didn't.
Yeah, I think like I said, there's more to it than that. Remember, Pluto's not a planet any longer.
There is no more to it than that. That's the facts. So
is Pluto a planet? I think you know what? Pluto will always be a planet to me. It's a minor planet. It's still a planet. I don't know. Screw the astronomy thing. It's their planet. Pluto has been a planet. I think it should be a planet.
It's still a planet. It's just
not according to them. They call it a dwarf planet, not an official planet. Yeah.
Planet's still in the name.
What did Pluto ever do to astronomers to deserve demotion?
Well, I guess because they kept finding more things like Pluto, and they realized, we don't actually have any rules to, define a planet.
Yeah, that was it. Yeah,
it's like, so okay, we're going to come up with some rules, and then unfortunately Pluto did not abide by those rules.
So basically, it was like the no true Scotsman fallacy for Pluto. They just kind of excluded him out. Poor Pluto.
Pretty much.
Yeah, even the live chat's sad. They miss Pluto.
I have a poster on my wall here that says, back in my day we had 9 planets with a little Pluto on the end. It was nice.
There you go. What was the thing that they in school they taught you how to remember the planets?
What was it? Something mother. I don't know.
I didn't have a mnemonic for it. I just memorized them.
I can't remember it either, but they had a really cool thing that you I just can't remember what it was. So let's change direction and tell us what a light year means.
A light year, okay. A light year is a measure of distance, more commonly known as a measure of time, but it's not. It is a distance. It is the distance light travels in 1 year. So just like how we have speed, so does light. Light has a specific speed that it goes. So light travels at 300,000 kilometers per second, which is another number in miles per second, I'm sure, but my conversion is not good. Do you guys know the conversion, Steve? Maybe?
Oh, wait, I'm sorry. What version of?
300,000 kilometers per second in miles per second.
Oh, crap. Miles per second is 186,232.16.
A lot.
Well, that's what it is in our unit of measurement here, and But yeah, I don't remember the
Yeah.
conversion
Yeah.
off the top of my head.
Yeah. So light travels at that many miles/kilometers per second. So when we multiply that number by the amount of seconds in a year, you get a number that's about 9.5 trillion kilometers, which is 1 light year. So it's literally just how far light travels in 1 year.
So when go ahead.
I was gonna say if something's 10 light years away, it takes light 10 years to get to us.
Exactly. Which also means that if you look up into the sky, no matter where you're looking, you're always looking back in time. You are your own time machine.
Wow.
Oh, explain that.
Let that sink in.
Yeah. Because light does take so long to travel. Like when we turn on a light bulb in our homes, it happens pretty much instantaneously because we are so close to the light. If we were to see a star explode, that's 400 light years away. When we see it explode, it actually exploded 400 years ago. So the light that you're seeing is 400 years old. Yeah.
So if it's 13 billion years away, so something like 13 billion light years away, it has taken 13 billion years to reach us. Ergo, young Earth universe thing debunked.
Yes.
Okay.
Yeah.
When there exists like our nearest star, Alpha Centauri,
mm-hmm.
I know that there are several plans to try to get there. With using light sail instruments and lasers to hit that and try to get it, I think, a 16th of the speed of light. How long would something like that take to get to a place like Alpha Centauri? And is that feasible?
About 20 years. And yeah, I think it's feasible.
But that isn't the clearest.
20 years.
That isn't the closest star, by the way. Anybody know what the closest star is?
The sun.
Yes! See, that's why she's smart. That's why she gets paid the big bucks to do stuff. Yes.
Well, yeah, obviously. I meant like the closest star to
actually wouldn't be Alpha Centauri either. I think it would be Alpha Proxima, is it not?
Right. Yeah, now? Proxima Centauri.
Yeah, Proxima Centauri. So.
But the Alpha Centauri star system is the closest star system to our sun.
Yeah. Yeah, we're all on the same page. A galaxy. What is the difference between a solar system and a galaxy?
A solar system is one star. Okay. A solar system is n number of stars interacting within their own gravity. So say you have our one star as their solar system. You can have a 2-star solar system. We have 2 stars orbiting around each other, and they're in their own thing. But a galaxy is a collection of many, many solar systems.
Interesting.
See, you learn on the non-sequitur show too.
Yeah, this is exactly what I kind of envisioned for this. Is just because there are so many aspects, I think, of space, and sometimes we don't really think about all the intricate pieces that kind of, make life exist today. There are thousands of different topics that you can cover with this, and I think that kind of going back to the basics to get everybody kind of on the same page, especially with us going into the flat Earth discussion on Wednesday. Some of these things are kind of blurred a little bit. I don't know why, but not all of us really grasp every single aspect of space. And there's just, like I said, there's thousands of different. Kirsten, I don't see how in the world you don't get just stay up at night thinking of different. If I was in that field of study, I would be asking 9,000 questions all the time, especially with being able to look through a telescope whenever you wanted to. I think you work at the largest telescope in Australia, or not telescope, the largest observatory in Australia, correct?
Yes, I did work at the largest optical telescope in Australia this summer. It was very fun. this big 3.9 meter telescope in Central Australia. Oh, sorry, not Central Australia. In North Central New South Wales. That was lots of fun using that telescope.
I used to go to Griffith Observatory. Ever heard of that? It's near Hollywood.
Mm.
Yeah. In fact, one of the earliest experiences I ever had was looking through the telescope. They don't often do it, but it was a four-star system. It was Gamma Andromeda, I think it was, and it's like a triple star system with 4 stars, and they had different oculars you can look through. And so there's one star, Alchemuk or I don't remember how it's called, and then you have to see 2, and then the next ocular you can actually see 4, and it's like, holy shit, this is like,
whoa, that's cool.
Yeah, I mean, quadruple star system, right? I mean, that's just like awesome.
Yeah, like next level.
I saw recently that they found, I believe it was on. Correct me on this. You probably know, but it was either Titan or Europa where they found oceans of frozen water, like.
That would be Europa.
How many meters thick? Europa,
yeah.
Would that be?
Europa has like a layer of ice about 20 kilometers thick, and about below that it's just all liquid water. We think. I mean, like obviously we haven't gone there yet, but we postulate that it will be that sort of structure.
And we're going to send probes there. I mean,
could there be life there?
Mm.
Could there be life there, Kirsten?
Yeah, probably. I think that would be more like extremophiles, like the sort of microbial life you find in the depths of the ocean. So there could be life out there.
I mean, it's got. If you figure if the core has thermal effects where it's actually has hybrid vents down there, then you might have a temperate zone in the water. And we're sending a submarine there, I think, in the next decade or two, to check it out.
Yeah, there's definitely thoughts about having one of those. So I'm very keen to see what they find.
It doesn't matter. We're all going to die at the end, anyways.
Yeah, true.
Does that raise an ethics question to either one of you in terms of if there is the potential for being life there, and us introducing an outside influence that could potentially harm or destroy that life? Do either of you see an ethics dilemma with that?
Definitely. Well, first of all, you need to worry about the actual probe contaminating what's there, what could be there, because we build these things on Earth. There's not an easy way that I know of to actually decontaminate this thing before we send it to Europa. So there's that problem to start off with as well. And then if they find something, if it's the ethical question then is like, we test it, do we destroy it, do we leave it, do we just observe? There's a lot of questions that need to be answered, which I think they're in the process of doing that as well.
Yeah, one of the reasons we destroy probes, like the one that just took the plunge, Cassini, one of the reasons they do is they don't want to potentially contaminate other planets. And yet here we are thinking about sending a sub, to Europa, which inadvertently could cause contamination. However, is there efficacy issues? Of course. Do I think that the scientific gain that we get out of it is? I think it's worth it. The greatest question we have to answer is there life out there? And I'm sorry if we have to fuck up one moon that nobody gives a shit about to get that answer. I'm okay with that. But hey, you know what? I'm not an ethical person, I guess. But seriously. I mean, I think that the bigger picture is that we have to explore, and we will be going to other planets at some point. We'll spread our infection to everywhere, and so why not start with probably a moon that might just have microbial life that can never develop to anything higher, and learn if there's life out there, because I think that our quest for knowledge is greater than that. And like I said, we have to go to other planets eventually, so we might as well learn as much as we can now, so we don't fuck up some other civilization down the line potentially. Does that make sense? I mean, it's kind of a weird way to say I'm okay with it. So
yeah, like our curiosity is just so strong that we just have to know.
Kyle, you agree with that?
Yeah, I can see both sides of it. I think. I mean, to say that life on Europa, if there was life on Europa, couldn't eventually evolve as we did, I don't think anybody can really know. It just may be as far out as they are. It can't happen, at that stage.
Hey,
I agree
it's
that
had 4 billion years to get there, dude. It hasn't happened yet. So
sure, yeah, but I agree to a certain extent that our curiosity, I think, ultimately overrules because you have to answer the question, is it there first? You could plunge into those oceans and find absolutely nothing, and then you're not really disturbing anything. But I can also see the argument that, okay, if we bring something, from here there that could in any way interact with the ecosystem that they have going on there, because you're talking about water too. If you introduce something into water, it's a lot different than just one probe on a planet that is isolated there. In the water, I think it'll spread, rapidly, and could, replicate a lot quicker.
Some sort of flowing system. That's right.
Sure. So, I don't know. Me personally, I think it's worth going and finding out.
You could also use the argument, though, that that's how we got here. Some civilization somewhere else sent a probe and sent it to this planet, and we were actually the contamination from them. Some kind of Pam
we don't know
thing. You don't know.
We don't know.
Yeah.
I think that's the beauty of another interesting thing where this whole ethics thing comes from is now they're talking a lot about the terraforming of Mars.
Yeah.
And how they would do that is build like industrial complexes like we had here at one point that would just shoot chemicals up into the atmosphere. And they say, based on their calculations, that they can heat Mars up 10 degrees. I think it's 10 degrees every 10 years, I believe. Wow. Ultimately, they're saying they could have Mars habitable in 100 years. But they are at the question of if there is life in the polar caps and underneath where the oceans kind of used to run, based on where they have the riverbeds and all that now. If there is dormant life there and we introduce all of these ways to terraform Mars, is that ethical to potentially destroy the Martian life that already exists or could exist on Mars?
Yeah, I guess all of these questions do need to be answered at some point before we do head over there. But
and guess what, Kirsten? Guess what? Those are questions that philosophy deals with, not science. So when people say, "Oh, philosophy is not important," this is when I go, "Hey, you know what? Philosophy deals with questions with ethics and questions with existentialism and existential questions." And so when people are talking, how do we use science and what does philosophy have to do with science? We don't need philosophy. Well, I think that's complete crap, because science is the tool, but without the parameters we put on it for like efficacy things and bioefficacy and methodological naturalism, science is useless. I mean, I think that obviously philosophy has a very big portion to play. Do you agree?
Yes, definitely. Like every field has, or almost every field has, a say in what, like a little bit of something that can contribute to these sorts of questions. Like the science answers how do we get there, the philosophy answers why should we do this, or what way should we go around this. And there are many different things that people will be able to contribute to this conversation of how do we get out of this planet.
If we did terraform Mars, this is an interesting question for both of you. Let's just play a hypothetical game of what if. Do you think it's a good idea to colonize another planet and have the two exist at the same time within each other? Or do you think that there's a potential eventually that human nature will take over and there will ultimately be a war of the worlds, if you will, where both planets will either fighting over resources or some other reason kind of destroy each other ultimately?
Well, one would hope that by the time we have the resources to actually colonize another planet, you'd think, fingers crossed, that, we'd be adults enough to actually live harmoniously on these two planets. But if history is any sort of indication, like it's already happened like with different countries. We can't even deal with countries with a bit of water in between them and territorial sort of thing there. Like, how are we going to get by this two whole planets with a bit of space in between them?
That's my question. I think that would just lead to disaster, on a big scale. It would just. I'm thankful that we'll be, as you said earlier, or as Steve keeps alluding to, we all die on the end, and I think that we're gonna be long gone before we have to worry about that.
Now you're just bumming me out, Kyle. Now you're just depressing me.
Let me ask this one last question before we ask or get the audience's questions answered. And if you guys have any questions, now's the time to put them through, and we will ask Kirsten. But Kirsten, how big is the universe, and where does it end, or does it end? And if not, how far out can it possibly go?
Okay, well, I'll start by saying the universe is real big. Really big.
I can follow that.
Yeah. So with the universe, like, it's so weird and wonderful, and I love it. Like, it's so big that it's so unfathomably big that we just can't comprehend just how huge this thing is. But there's also, like, it's really weird in a way that you have this size, but there's no edge to this size. There's no edge, no physical edge to space. There's a physical edge that we can see to, like with current technology. Like, we have an edge that we stop seeing from, but physically there is no edge to the universe.
And how do we know that?
That's a good question. That's a very good question.
Thank you.
I am not sure, actually, how we do know that. Steve, any idea?
The way it works is kind of like this. If you think of a sphere, right? There's no end to that sphere. You basically can go on forever. And we know that gravity warps space-time, and so we know that there is no non-Euclidean space. There's no Euclidean space. It's all non-Euclidean. So basically, the whole space-time is going to wrap upon itself. So it's basically a three-dimensional structure that has no edge, because it's basically, think of it as a sphere. So no matter how far you go, you're basically curving as you go. There's no such thing as a straight line in space. And all gravity does is basically the shortest distance between two geodesic points. And so anything that has gravity, that like light's going to curve, you're going to curve, and supposedly you're going to kind of bend back to where you started. Now, there's kind of some problems with that, but that's the easiest way to kind of explain it. So there's no edge. There's the observable event horizon, right? The observable event horizon is the point where you're not going to be able to ever see anything past that. Everything past the observable event horizon forever is out of our reach, because it is moving away from us faster than light can actually reach us. So we can never get there.
There will be a point in time and space where all of the galaxies that are not our own will be moving so fast away from us that we will not see the light from those galaxies.
Yeah, they'll be redshifted.
It'll be a very dark.
Yeah.
That's crazy. So, I guess my final question will be one that I think you get a lot more from the religious side that asked this, and I'm not asking it in that context, but what existed before the Big Bang? Like, before we went outward, where was the universe, and what was in that space before then?
The mind of God.
Isn't it? It's just a vacuum, I guess. I'm not really sure. I did a bit of research into this for a presentation that I had to give for my class last semester, and my presentation partner was talking about this sort of stuff a bit more, but it's kind of like I forget the word, what it is, but you have kind of like this space that never ends sort of thing, and then suddenly there's this little tiny Big Bang that happens, and suddenly we're
Metastable false vacuum or quantum fluctuations.
That's the words I was.
But the problem is, Kyle, it kind of is a non sequitur. Get it? Non sequitur. It's kind of a non sequitur. It's a non sequitur to ask what's before the Big Bang. It doesn't follow. It really is not a nonsensical question. However, there are some theories out there that state that there could have been a situation existing in a different universe prior to ours, that it's not before the Big Bang, but it's relating to the universe that we have now, where entropy was opposite. So basically, in our universe, we have entropy where you go from a lower order to higher disorder, right? So entropy is increasing for the universe. Well, in that situation, it was the opposite. The universe started from a very high entropic state, going to a very low entropic state, and then the Big Bang occurred, and then we have the expansion and low entropy to high entropy. But it makes no sense to even ask really what is before the Big Bang. But I think you're talking about quantum fluctuations, because
Why?
Because, well, there's nothing before the Big Bang. It's a nonsensical question. The Big Bang, when you're dealing with
there had to be something
zero,
before the Big Bang. It had to come from somewhere.
Time didn't exist, so how could there be anything? Literally, there was no time. So to ask what had happened before the Big Bang, there was no time for there to be anything.
Hang on a minute. Wait a minute. When the Big Bang happened and we all kind of flew from somewhere, obviously there had to have been something before that. Before
time didn't exist.
Came from.
Somebody asked in the
we don't know that. I mean, we don't know that for sure.
Well,
we don't know that for sure.
Construct that we've come up with.
Somebody had asked about the book of Megapoint. Yeah, I read back in the day the Megapoint, the Dancing Woolly Masters, all that Tao of Physics. But if you took all of it, right, back then they thought that the universe would explode and basically it would start slowing down. And it wasn't an explosion. I'm using it colloquially. There was no explosion. But the universe would expand, slow down, and then start coming back. The gravity would start to bring it back again, right? The big crunch.
Crunch.
Yeah, but subsequently we have realized, because of dark energy, that the universe is not only moving away, it's not slowing down. It's actually accelerating.
Right.
So that pisses all over that theory, right?
Sure. Yeah, but I still think that I think just common sense wise, the Big Bang started from something, and I'm not going into the religious aspect of it because I don't believe that there is a religious aspect of it. But those pieces came from somewhere. I think
so.
That's the fascinating. Kirsten, when we have you on next, we need answers to that question. Okay, so make sure that you go out and you find the answers to that.
Yeah, just win the Nobel Prize for us, will you, please? Because if you did that, I think you'd probably win it. If you could discover what was before the big,
So like in my undergraduate level of university, right? Like
compared to us, you're epically beyond us. So I mean, it's all good. We're not even in school for that shit. So we don't know a goddamn thing. Half the time we're just making up as we go along, and Kyle just nods. That's all we do.
But I have such a beautiful nod. I have mastered the nod. Steve, do we have any questions? And before you ask them, remember, guys, as soon as we get done with your questions, stick around because we're going to play the trailer for Wednesday. So make sure that you stick with us till the end. You're going to want to see that. And I will turn it over to Steve to see if there's anything that anybody in the chat would like to know.
All right, chat, go ahead and start asking. I could ask her questions for the next 10 hours. I mean, we could be at this all night. So, but you guys don't want to hear my questions. So, quick, Kirsten, if you can wait, try to fit that in the unified theory of quantum theory if you're not too busy. I think this person, Godless Iowan, wants to basically ask, can you rectify or reconcile quantum loop gravity with general relativity? It's kind of what he's asking.
Ooh. That's very much above my knowledge base. I'm sorry.
Don't feel bad. Nobody freaking knows. Just do it. God doesn't nod and agree. Yeah, who the hell knows Iowan? Nobody solved the quantum field theory yet. So when it comes to that, so
exactly, yeah. It's kind of like this magical thing that's there.
Reese, it's all magic. Yeah. Reese wants to know will our moon collide with Mars or be adopted into its orbit?
That's a good question. It is moving away from the Earth. I think it's about 3 centimeters or so, about an inch, just a bit more than an inch each year. So it will slowly move away and then keep moving away. But for it to be adopted into Mars's orbit, Mars probably had to be very close to us by the time that it, gets far enough away that it's not a moon of ours anymore. So it could happen. I don't think it will, though.
Yeah, I have no idea. Mars, I mean, assuming the moon is receding, obviously. But
I mean, it could even be adopted into Venus's orbit. Who knows? We can do models and stuff, but I'll leave that to the people who are good at coding.
Well, have you ever heard I use the term theory colloquially here, but I mean, have you heard the theory of that Venus was once a comet that came out of Jupiter?
What?
Yeah, that's something called electric universe theory that came from Velikovsky's World of Collision. But that's out there, yeah. That's don't try to figure it out. But if you ever hear that Venus was a comet that got ejected from Jupiter, that is EU theory, and it's based upon Velikovsky's work. So.
Okay, cool.
By the way, it didn't happen. Just FYI. Okay, what other questions we got?
No.
How do we measure light speed? Somebody's been asking. How do we measure light speed?
Okay, well, we can measure light speed just by you have in your lab. You can have a laser which produces light, and you have the transmitter and receiver. You measure the point when the transmitter went off, and then measure the point where the receiver received that signal. You know that distance between the two receivers, and then you work out the time it took, and then from that you can work out the speed. Pretty simple stuff.
And can anything go faster than the speed of light?
It's technically the ultimate speed limit, but like light moving past, not in, but moving past a black hole should technically be moving faster at a single point within that path, but the average speed over that path would be the speed of light from my knowledge.
Okay. I have to look.
So we'll just go with.
We'll go with that.
No,
yeah, that's weird, but okay, yeah. The answer no, it doesn't. Nothing goes faster than the sea. However,
no.
There are ways of working around that, and maybe that's kind of what you're referring to. Ever heard of what's called the Accuberry metric? And I'm probably butchering his name. He's a Mexican physicist. He has actually developed warp equations, like seriously Star Trek warp type equations. And the way the metric works is that you ride the wavefront of space-time, so space-time itself is moving, and you're riding the crest, so you're not really nothing's going faster than c in the space-time, but you're riding the wave, and that's moving faster than c. So we can actually get to another planet no time, if that was the case. There's only one downfall. It requires more energy than the entire universe can provide for us right now. But the math works, supposedly.
Yeah. Look, if the math does it good, then I guess we're good then.
Yeah. Fuck math. Yeah, that's the flat Earth. That's the flat Earth motto. Math is just a thing. It doesn't represent reality.
Yeah.
Why do people even still? I don't know. I can't even ask that because I know that won't be taken seriously. But do we really need to teach math anymore when we have phones and computers that will do it for us?
Yeah, exactly.
I mean, really.
Yeah.
Good point.
Good point. Yeah.
I mean,
why learn anything when you have Google, right? You don't need don't study anything. You just need to know something. Just go look it up, or type it into a computer program, right? It does all the work for you, like calculators. Yeah. Somebody wants to know: have you ever seen a star born? We're seeing born right now. Dun dun dun. Superstar Kirsten.
Oh yeah. Bravo, Steve. Bravo.
No, I haven't seen a star being physically born because that process is over many years. So it's not like a light that just turns on. So I'm going to say no, I have not seen a star being born. Nor have I seen a star dying, but I'm hoping that will actually happen sometime in our lifetime.
See, I would probably say we have seen it depends on what you mean by born. I think we've seen the ignition point. We've seen a star being the point where it has gone from not having fusion to undergoing some type of fusion in a preliminary stage by Hubble.
Oh yeah, for sure.
So if that's what you want to call born, I'm okay. I think that I would call that born. Now, what do you mean by, like you said, it's so long of a period of time. What is the point where you say this star is born, right? So it's kind of a weird question in that way. Yeah, I agree with you on that.
In that case, technically, I have seen stars being born because one of my favorite objects in the entire night sky is the Orion Nebula. I just looked at it just a few nights ago as well, and that's a star-forming region. So I guess technically, when I look at that, I am seeing stars being born. So.
And Betelgeuse could go up any time.
It
might have already exploded. I mean, it's possible. I mean, it's right on that. They say it's right there, the cusp. And I still think it probably tens of thousands of years from now. But man, if that went up, that'd be an awesome display. It would be like as bright as the moon. The problem that it would only last like a few seconds, and so if you weren't out there at the right time, you would miss it, and it would suck because that's a once in a human lifetime event to have a supernova that close. Fortunately, it's tilted away from us, so it's not going to have a gamma ray burst to us. We won't die. It'll just be a cool little show, but
it'll be good. But it'll be so cool. Like you'll see it during the daytime, and if it happens during nighttime, you'll be able to read a newspaper from the light.
It'll be really quick, from what I understand. It's just going to be like, and then kind of just so it's going to happen very quickly.
It is very quick. Like the first blast is very quick, but the cool down period is a bit slower.
It'll still be bright. Yeah, it'll still be bright. Sure.
Yeah, it'll still be bright for a number of weeks.
Yeah,
so.
But it won't be that initial burst of light where you're gonna go, read something. I think that's only gonna be a few seconds, but
Yeah.
But God, can you imagine going outside and seeing that? That'd be so awesome.
Dude, I really hope it'll be within our lifetime. Like astronomers say soon, which means within the next million years, but I really hope it'll be actually soon.
Soon is a million years for an astronomer, yeah.
Yeah.
Is it true that you can't hear things, like if an explosion was to happen in space and you weren't here, like on Earth, that you wouldn't hear it, but you'd be able to see it? Like nothing makes sound in space?
That is correct, because the sound needs to have a medium, so like air, for it to pass through. Because there's no air in space, you can't hear sound in space. It's like what they say, no one can hear you scream when you're in space.
Exactly. Yeah, there's like 1 proton for every cubic centimeter or something, or 1 or 2 protons per cubic centimeter, so that's not enough to carry a sound wave. That's why.
Yeah. So no sound, just...
Right, yeah, who doesn't know that?
Like I said, I don't know. We just make the shit up as we go along, we just nod, that's it.
No, see, who doesn't know about the proton?
The live chat keeps us honest. I mean, we have the smartest freaking live chat I've ever seen for any show. These guys are on point. I am not kidding. They know this stuff. If I mess up, they're like, Steve, no, bad Steve. I'm like, oh, okay, let me fix that. So what do we got? Questions for Kirsten?
Excellent.
Let's see. Oh, here's a good question by Zeth. Why is C constant? Ooh, that's actually a deep question. Why is the speed of light the way it is the speed of light? You know what? I'm gonna let you take that one.
Excuse me while I Google that question.
I'm just gonna go with it's just the way it is. It's fine tuned, and I'm not using a fine tuning argument, but the natural units. There's a whole bunch of natural units like Planck length, Planck's constant, gravity is a constant, light. They're all natural units, and they can all be. You could find one constant from another constant by using matrix theory, using quantitative analysis. And I just think that the universe is what it is. There's no rhyme or reason for it. I don't believe in the principle of sufficient reason when it comes to certain things. So it just is. It's a good question, though. I don't.
Well, see, like the thing is with a universe, you have certain physical constants within that universe. So there could exist another universe where the physical constants are different from ours, and then that speed of light would be different.
Oh, I misread the question. He wasn't even asking the question. He was answering the question. Oh, but still a good question. Whatever. It's still correct.
Still.
Yeah.
Also, the answer is 42.
Answer's always 42.
Yeah. Always 42.
Yeah. Let's see here. What else we got? Come on, people. Okay. We need a little more complicated questions for her. Come on. She's undergraduate, but she's going to school. I've seen her work. It ain't freaking easy. She knows her shit. Come on, give her a challenge, people. But not these unanswerable questions. You're asking questions like nobody knows, right?
Yeah.
Yeah. Yeah, I mean, Eric's answer is good. He says C is a constant because the laws of physics must be the same for all inertial frames of reference. Okay, I'll go with that.
Yep, I like that.
Yeah. Trevor asks, any guesses as to which of the observed protoplanetary disk will be the soonest to yield first light? In other words, which protoplanetary disk are we going to see to be as an actual planet that's in formation? I think that's what he's asking.
Okay. So like when you have a star forming and then within that disk you have planets forming in there too?
Yeah, you have the accretion
Kind of.
disk, and you have protoplanets forming, and then I guess eventually they congeal, and you can actually start have a planet. So I don't
So
know. I
when
don't know
will
what
we
he's
actually
asking.
see?
Yeah, I think he's asking when we're actually going to be able to see one. But if we already seen it, then it's actually
Okay.
formed. So
Well,
I
I
don't
mean, like,
understand the
yeah,
question.
because you can look at it with probably infrared light, probably would be the best one to look at it with, because then you'd be able to see these hot spots of where there's more stuff that's heating up, that's spinning faster as well within this protoplanetary disk, and that would be where a planet would be forming, I would say.
Okay. Let's see what else we
Yeah.
got here. How many turbines are on a star? That's a good question. No, that's not a good question. We're not going to ask that. Do turbines prove God? That's a good question.
Do turbines prove God?
Yeah, it's an inside joke. Just say no.
Okay, I'll go.
um, let's see here. How does parallax work? Oh, that's a good question. How does parallax work?
Ooh, okay, so parallax works. It's basically a okay. How to imagine this is parallax works with closer stars. So when we're on, so you have the sun and you have the Earth. When we're on this side of the Earth, we see a star that we want to measure its distance to, and we measure its relative position to background stars. So stars long behind this star, right? And then you go onto the other side of the sun, we move around, and now we see its relative position has changed based on the background stars. Using this, we know the distance between these 2 points from one side of the sun to the other side of the sun. We know the angle it has made here because we can measure that from the relative positions of this star to the background stars at both sides. And then we just do some Pythag. So it's literally just Pythagoras theorem, just triangles and stuff and angles.
So if I close my eyes and go like this back and forth to my finger, that's parallax, right?
Exactly. Yeah. Exactly. Do that right now. Try use a wall, use your finger, look at it with one eye closed, look at the other eye closed, and you'll see that it changes.
Yeah. So the closer stars are going to move. They're going to have a greater degree of variance with respect to the fixed stars that are further away. And we've referred to the stars that are very far away.
Yeah.
The parallax is so low, we consider them fixed.
Yes, exactly.
Oh,
also, I like how you did that, Kyle.
He's still working on it. Yeah.
This is totally me just nodding and pretending like I know what's going on. But any words over 3 syllables and my brain just automatically shuts off.
Oh God, Zeth asked a really good question, but I don't think this is something that you may know much about because this is kind of fringe stuff. But Zem asked, "What are your thoughts on the EM drive supposedly breaking the law of physics?" Are you familiar with that in Australia? You may not be.
Yeah, I've heard about the EM drive. I don't know how I haven't heard about it supposedly breaking the laws of physics though.
Yeah, it doesn't. That's the reason.
I didn't think so. Yeah, because it's just another propellant system, but propelling radiation instead.
Yeah, exactly. Yeah, it just basically has a resonance chamber and it is actually turning into heat, but it's so inefficient. You would literally need a shit ton of them to do anything productive. So yeah, it's the cold fusion. It's the cold fusion of propulsion. What's that?
Yeah, and plus it'd only be useful for long distance because you're right, it's really inefficient. It takes so long to actually speed up. But if you're doing that over a very long time, you'll eventually get to a very high speed, but then you'd have to slow down to get to where you want to go, and it's not helpful.
Yeah, people think it's going to be like it's going to solve all our energy problems and shit. No, I'm in the camp firm believer that over unity is just like anti-flat Earth. I mean, it's just over unity does not happen. You cannot have it. It doesn't exist. It's a myth. They need to get over it. Sorry, you're not going to violate the second law of thermodynamics. you're screwed. I mean,
Yeah.
have you seen people that still are promoting this perpetual energy crap? I mean, do you ever watch them? They're so adamant that they've discovered perpetual energy, and they're getting more energy out of a system than putting in, and yet every single time it's always a flaw in their measurement, an incorrect setup in the experiment, and I think the ubiquitously among scientists now is just it's impossible. Don't even try it anymore. So
Yeah, look, it just can't happen, really. I mean, like, it'd be really cool if I can be proved wrong and that we can be proved wrong and it does happen, but at this day and age, I don't think we just know.
Yeah. So Tom34B, my friend, he asked, what does Kirsten think about the multiverse?
Ooh, I like the multiverse. My favorite multiverse theory is the bubble universe, because bubbles. But like, on a more scientific note, it's really cool because you do have these bubbles that we are in a bubble, which is our universe, and we can only see to the edge, even though we've already talked that there's no real physical edge of that bubble. So, but then there are other bubbles as well that don't overlap, that are other universes that only if you are inside of that universe you can see what that universe is like. So I like bubbles.
Okay.
Does anybody else have any questions? I mean, I'm just kind of slowing down the live chat. What questions do you have for us, Kirsten? How about that? Knock yourself out. Ask us questions.
Okay. I really get asked to ask questions, so I'm stumped at the moment. But I just
we already stumped her. We didn't even have to answer any questions. We just stumped her right off the bat.
That's true. Yeah, I don't usually ask questions. Well, I do.
Ask us something about astronomy, or ask us something about cosmology or science. Pick our brains. Not that we know shit about it.
Yeah.
And by us, it's going to be very, very. He means Steve.
Well, no, I want Kyle too. I mean, it could be really bad answers, but go ahead, ask us something.
Okay. Can you explain to me cosmological redshift and how it's different to the Doppler redshift?
Cosmological redshifting.
All yours.
Oh, I was going to say, let Kyle answer this first. Doppler redshift is actually due to the fact that you have sound waves that are longitudinal wave that are going to be compressed, and refraction where they're moving like this. And when you have an object that's moving away, the wavelength is actually spread out. So you have the sound is going to be getting lower pitch, and as it's moving toward us, it's going to be compressed. So you have a higher pitch. The cosmological redshift is similar when it comes to light, such that when light is moving to us, it's if you look at the spectral lines, where you have absorption lines or emission lines, where in a spectrum of a contiguous spectrum, if you have an element, that element will absorb a certain frequency or emit a certain frequency, depending on which kind of spectrograph you're looking at. And so these lines exist in the spectrum of light, and when you have a star moving away from us, those lines are going to be shifted to one side of the spectrum or the other, either to the blue end or to the red end. And that's what we call the cosmological redshift. Is that a decent enough explanation?
Cool.
Is that way off base or not close enough? Okay.
No, I like it. That's good.
That's the best you got?
I am trying.
Yeah.
Come on, challenge. Come on, give me a challenge. Come on.
I have so many things in my head right now. It's like, there's no room for anything else.
Yeah, no, I hear you.
Yeah. Oh, there's a question on the chat though. Why doesn't sunlight freeze before it gets to Earth?
Ooh. That is interesting.
That is interesting.
Kirsten?
I mean, light doesn't necessarily freeze. Light is just like a frequency. It doesn't have... Well, I can't say it doesn't have heat because it does, technically. Why doesn't it freeze? I don't know. What are your thoughts, Steve?
Free. Okay. Well, freezing has to do with kinetic energy, and so when you have a
Mm,
particle, what temperature is? Temperature literally is kinetic energy. So
yeah.
when you have a particle that's like moving, like resonating in something or vibrating, that's going to produce heat, right? Um, so heat has to always be also in motion. You can't have any kind of heat not in motion. It has to be moving. But light itself
Yeah.
is not a
That,
kinetic energy thing. Light itself is a wave of energy, but it's not. It doesn't have mass, right? There's no mass involved. You have no kinetic energy per se. You have what's called uh, photonic momentum, where, for example, like light will hit something, it'll impart energy to it, which is a type of kinetic energy. But it's not like you can't raise or lower the temperature of a light wave. There's nothing to raise or lower. It's literally energy itself going through a medium, if that's the way you want to look at it. Technically, it's propagation
yeah.
of a quantum packet. But um, yeah, I don't. There's no temperature involved for that itself. There's infrared. This is going to be a weird way to kind of say it, because obviously infrared is a form of heat, and obviously light does have the ability to
Yeah.
impart energy. So, but you can't change the energy itself of the photon itself. We can't change the kinetic energy as far as the thermal energy of the photon. That's a
Yeah.
weird way of saying it. I think I kind of butchered that, and so live feed, don't just ignore everything I just said. But
Yeah.
I mean, how would you
You
describe
Get
can't
it? I mean,
him.
like hearing what you're saying. Like it all makes sense and everything. So it's powering through my brain.
I'm just gonna say I'm
But
just gonna say God because of reasons. Yeah.
because of reasons, we can't do that though. Because then we're no good than the flat earthers. Like why do you see a mountain from the top only for and not see it
Yeah,
the
no,
entire thing? Like, oh,
yeah.
because your
Stephen
eye
makes
works that way. It's like we can't do this, Steve.
Yeah, well, Stephen Curtis makes a good point. He's like, photons have no charge, and they don't interact with anything. Although impulse, I mean, they'll hit something, they can be absorbed like a atom would absorb a photon, and you have a electron
Yep.
jump orbital, but they don't like radiate anything as they're passing through, right? You don't
Mm.
have a photon, you don't have it radiating out things. Normally
Yeah. Like
heat, you have
an internal
radiation that comes
energy.
out, thermal radiation.
Yeah. Like is it like an internal energy, not an external energy
Yeah,
in a way?
yeah, it's an internal
Yeah.
of the quantum wave packet itself.
Mm.
That's the best way to describe it. I think that's good.
Yeah.
Come on, people! You have Kirsten here. Ask her questions. She loves this stuff. I'm not kidding. She likes to be challenged. She's not a
I
special
do.
little snowflake here. She could take a hit. Come on, give her something good. Um, they got nothing, man. They got nothing for you.
That's a good sign, though. That means that we answered all of their questions.
Yeah, we did a pretty good job then.
Um,
And plus, like, if people do have questions that they haven't thought of now or they think of them later, they can always go to my Twitter page at Astro Kirsten and send them there.
very true.
Oh, Starkey asked
And
a question
when
twice.
or
Go ahead. Sorry. Somebody asked a question twice, and I must have missed it. Uh,
what is the question?
I'm trying to find out. Ask it one more time, Snarky. Oh,
While he's getting that,
go ahead.
Kirsten, tell us when your TV show appearance is going to be again.
It should be in August from memory.
Where would we be able to find that here? Like
It,
what channel?
I'm not sure what channel it'll be on. So they're still in the process of editing and filming and all of that. So when I do know, I will let you know as well.
Her
Of course.
question was something we already answered. That's why I think I did see it, but I thought it was an old question, because what happens is when I go back to the tab, some of the old questions come up, or the old things in the live chat. But she had asked about the Andromeda actually colliding with the Milky Way and how that would affect us, and we kind of already talked about that it wouldn't have
Oh,
any effect. It would be cool. It would look awesome, but
yep. It would look fantastic.
Oh man, just trillions of stars everywhere and crap. But yeah, we wouldn't be affected. The stars are so far away from each other; they're not going to collide. The odds are extremely rare, and it'd be very nominal. So.
Yeah, exactly. Like it's like what we say. There's so much space in space. That's why we call it space.
Oh, Trevor's got a really hard question, and this is something yeah, she's not going to know this, Trevor. I'm going to ask it, but and again, I'll be impressed. I think this is a PhD more level question, but why is the sun's corona hotter than the surface? That's a hard question, and if you haven't read the literature, you probably wouldn't know. But it's a good looking question.
Isn't it something to do with magnetic heating?
It's what?
Isn't it something to do with magnetic heating?
It's similar, yeah. It's similar. They're called microflares. They determined the explanation for that about 2 years ago. That due to what's called microflares and magnetic, like you said, magnetic heating, that the corona will have a higher temperature. They've actually kind of resolved that, I think. But yeah, damn. See, she knows her shit. People, don't mess with her. Yeah. But yeah, that's good. Wow.
Yeah, it's cool stuff.
So yeah, I think that is a good stopping point. Fantastic discussion, as I know it would be. Kirsten, I can't thank you enough for.
One last question. We have one last.
Sure.
Greg, from our friend Goddess Iwin. What is the speed of dark?
Oh, that's a good one.
You know what? We're not even going to let that. We're not going to answer that. We're going to let you guys think on that one. We'll just leave them hang on that one.
I'm going to go home and like think about that one too. Actually,
yeah, that's a great question. People ponder that one. What is the speed of dark?
Yeah.
Leave it to Godless Iowan.
No kidding, right?
Leave it to Godless Iowan.
I think I'm supposed to get a file here that I'm supposed to play.
Well, yeah, but it's too large for me to send externally out here. So
we'll have to do another time.
What we're gonna do is, I'm gonna load that as a separate video. Here in about 5 minutes, I'll just upload it to YouTube as a separate thing. So the trailer will be uploaded in about 5 minutes. It's just too large for me to send to Steve to put it up on OBS from here. But that's what I was actually doing in the past 15 minutes, but it's not, it's too big. So I'll upload that as a separate file here in about 5 minutes, so you can catch that. But Kirsten, thank you so much for coming on and entertaining our questions. I hope I did a really good job of pretending like I knew half of what you were talking about, although I'm certain that I did.
I think you did a very good job.
Interesting. Thank you. Interesting nonetheless, though. Do you have any parting words or anything you'd like to say before we close out?
I'd just like to say to everyone, thanks for enjoying this chat and sending in so many great questions as well, and sticking with all the stuff that I say. Sometimes I do stumble on my words, and I do appreciate that people do stick around to understand what I'm trying to say. If you do have more questions, send them to my Twitter account at AstroKirsten. And if you recognize me in the street, don't hesitate to stop and ask questions there too.
Yeah. By the way, we all do it. Did you hear me butcher the whole light freezing thing? I just screwed that all to hell. So yeah, don't worry about it. We all do that.
This is why I do physics and not English, because words are hard, numbers are easy.
But I want to thank you as well for coming.
Unless you're Trump.
Unless you're Trump, there you go. Everything's hard for him. So with that, I think we should bid everybody good night, and we thank them for watching. Kyle will be uploading a teaser trailer, I believe. Is that kind of what it is? A teaser trailer here in a few minutes?
It is.
Okay. And then our next event we got is
Reds on Tuesday.
Reds on Tuesday. So Reds Rhetoric, and I think are you coming back? You're gonna be here on Thursday? No, Tuesday. I'm sorry, Tuesday. Kirsten, is it Tuesday? I think.
Will I be here on Tuesday? Maybe. I'm starting to get very swamped at uni now.
All right, we'll figure it out. But anyways, we're gonna leave with that.
I think that was supposed to be a Sunday thing, Steve. But Reds was tied up. He was actually supposed to, or we asked about joining tonight. So that's a
and then he wants, then on Tuesday we're gonna have something. I think. We'll figure it out. We tell you guys. We'll let you guys know. Don't worry. But anyways, Tom said great show. So we're just gonna leave with that, right? And we agree. Thank you very much for watching, guys. Good night.